We start our
You can start, teacher, yeah.
we start our lesson, and today is theme 6, interchangeability of threaded connection. We have the plan of our lection. Please write down to your notes our plan. 6.1 basic parameters of cylindrical threads. 6.2 general principles of interchangeability of cylindrical threads. 6.3 total tolerance of the average thread diameter. 6.4 reduced average thread diameter. 6.5 tolerances for metric threads. 6.6 thread accuracy degrees. And 6.7 designation of thread tolerance and feed tolerance fields. Please write down these 7 items of the plan. Please tell me when you finished this slide.
Yes, okay, teacher.
Okay, next slide. It's
Yes,
our 6.1 item, basic parameters of cylindrical threads. A threaded connection is a connection of two parts, one of which has an internal thread and the other has an external thread. Please write down to your notes. Common to all threads are the requirements of reliability and connection without adjustment independently manufactured threads parts. It is much more difficult to fulfill the requirements for the interchangeability of thread connections than smooth ones. Since several parameters simultaneously influence the nature of the threaded connection. Now you can see V profile for ISO general purpose metric screw threads. Cylindrical thread parameters. Average or middle diameter. D with suffix 2. Average or middle diameter. D2. This line it's average or middle diameter. Outer diameter, D without suffix, small d or big D. Small d we used for the bolt and big D we use for the nut. Nut have the internal thread and bolt have an external thread. External thread bolt and internal thread nut. So outer diameter is D without suffix, big D or small d. Big D we use for the internal thread and small d we use for the external thread for the bolt. And inner diameter. Inner diameter D suffix 1. This line is inner diameter of the thread connection. It's outer diameter and inner diameter. So we have average or middle diameter, outer diameter, and inner diameter. Inner diameter. Then we have a pitch. Pitch, big P. It's this distance. This distance, it's a pitch. Profile angle for metric screw threads, its profile angle is equal 60 degree. Alpha is equal 60 degree for the metric threads. The height of the original triangle. The height of the original triangle. There are original triangle from this to that. It's original triangle, and H, it's a height of original triangle. That's all the parameters of the metric screw threads. Please write down to your notes this figure with diameters, outer, inner diameter, and average or middle diameter, with the pitch and H, the height of the original triangle, and with the profile angle that is equal 60 degree. Okay, the thread pitch, P.
Okay, teacher.
The thread, oh, excuse me, previous slide. The thread pitch, P, this distance, these dimensions. The thread pitch, P, is the distance between adjacent profile sides of the same name along the average diameter or middle diameter. Metric threads come in large and fine pitches. One more figure with metric thread. Metric threads come in large and fine pitches. For a thread with a large pitch, there is a dependence. D is equal 6p powered in 1.3. For threads with fine pitch, different pitches can correspond to the same outer diameter. What we can see in this picture, in this figure? We can see pitch diameter or middle diameter,
We can see the pitch and the diameter of the pitch and the diameter of and the angle. So
angle 60 degree for metric threads, 60 degree. And we have tolerance fields for the nuts and for the bolt. It's nut и bolt. So this blue field, it's tolerance field for the nut. And this yellow field, it's the field for the bolt. It's tolerance field of the bolt. You can see the tolerance, this distance, in outer diameter of the nut. And you can see tolerance field in inner diameter. Of the nut. We can find tolerance field in the pitch diameter or middle diameter. It's tolerance field on the pitch diameter. Of the nut. And for the bolt, tolerance field in outer diameter. Tolerance field in inner diameter. Of the bolt. And tolerance field in the pitch diameter. From this point to this point. As usually, we have a clearance between bolt and nut. We can't have no, we only have the clearance between these parts. And this line, it's a basic thread profile. Basic thread profile. Please write down to your notes this formula and this picture and this figure.
okay, teacher.
Now I want to show I want to show to you some videos. With thread connections. It's thread anatomy. What types of thread we can use, we can see. We have major diameter or outer diameter, minor diameter or inner diameter, and pitch diameter or middle diameter of the thread. It's external thread of the bolt, and it's a pitch, thread angle, thread depth. Types of thread. We can see a 9 type of thread. Metric, it's the most popular type of thread, metric thread. Inch, Whitworth, Acme, modified square, buttress, sharp V, worm, and knuckle. Metric thread. The ISO metric standard screw thread has a 60-degree pitch angle, 60-degree pitch angle, with a flat crest and a rounded root. Uses pitch to define thread. Example, M8 for 1.25 is equal 1.25 millimeters from root to root. It's a pitch of the thread. 1.25. It's from root to root. And this type of thread, general use for standard assemblies that need to be bolted together. Next type of thread, inch. Has a thread angle of 60 degrees with a flat crest and a rounded root. With word. The first proper thread standard, coarse thread pitch and basic radius of at both the peaks and root of the thread. And what we can see the angle, it's equal 55 degrees. And the usual use for standard assemblies that need to be bolted together. Next type, acme. Trapezoidal thread form with a flat crest and root. These threads are one of the strongest symmetric threads profiles. General use for controlled movements on machine tools, testing machines, jacks, aircraft flaps, and conveyors. Modified square. Similar to the Acme thread, the modified square thread has a trapezoidal profile, but with a much smaller pitch angle than an Acme thread. It's 5 degrees. In Acme thread, it's 14.5 degrees. So that is the difference between these two threads. 14.5 degrees and modified square have the angle of the 5 degrees is equal 5 degrees. And where they used this modified square? General use, since the pitch angle is small, it has low friction and it has a high transmission efficiency. Butters. Threads with an asymmetrical pitch. Asymmetrical pitch. All previous types of threads was symmetrical, have a symmetrical pitch. Now this type of thread have asymmetrical pitch. And general use, high loads and heavy lifting, transmission threads in tuning and milling machines. Sharp V. Peaks and roots are sharp. This allows for the same cutting tools to be used for all pitches. General use meant for locomotive work because it naturally forms a steam tight joint when machined correctly. Machined correctly. Worm. Trapezoidal threads that are similar to Acme threads but have several rules concerning pitch and can have multiple starts per worm. The angle is equal 29 degrees. General use to drive worm gears and are means of speed reductions and power transfer. And last type of threads is knuckle. Consists of a highly rounded threaded form, rounded. These threads are highly resistant to debris and where, since there are no sharp edges for anything to catch on. General use desirable for high load operations where debris can be an issue, such as mining, locomotive, and industrial applications. Next video. Basic isometric threads profile. It's a video about metric threads, the most popular thread in the manufacture.
Metric thread profiles are often written as shown. This is an example of a 12mm thread, where M stands for metric, 12 describes the major diameter of the thread, and 1.75 is the pitch. There are additional classifications sometimes written after the pitch, such as tolerance, but there is a lot to explain on this, so I'm going to go into this in another video. The important part to know is that the major diameter refers to the largest diameter of the external thread. External, meaning the screw or bolt, and the pitch, P, is the distance between one tooth section focal point and the next corresponding point on the next tooth. International standards such as ASME B1.13M detail widely accepted thread diameter and pitch combinations. Here, I'm showing some of the most common coarse and fine type pitches for major thread diameters up to 36 millimeters. The thread consists of an internal and external component. The internal part is the nut, and the external is the screw or bolt. The major diameter or radius for the benefit of this cross-section is the largest thread diameter or radius. It is often also known as the crest of the thread. The pitch radius is the effective radius. The minor radius is the smallest radius and often describes the root of the thread. The pitch, as explained before, is the distance between tooth profile sections, and the surrounding geometry for the thread can be worked out by knowing the pitch. The thickness of the tooth at the pitch radius is half of the pitch. The crest is P over 8, and the root is P over 4. Metric thread teeth are set at 30 degrees regardless of the diameter. H is the height of the fundamental triangle, and this can be worked out by using P. So H equals square root of 3 over 4 times P. Distances and relationships between major, minor, and pitch radius can be found from partitioning H. The crest to the peak of the triangle is H over 8. Root to base of the triangle is H over 4. And here the equations show the pitch radius is positioned at half of H. If we overlay the nut, the major, minor, and pitch radii intersect the mating part. Both P and H are relevant. The crest and root of the nut are identical to the thread, and this is shown by P over 8 and P over 4.
Please write down to your notes this scheme, this figure.
Okay, teacher.
With all these dimensions. If you finished, we can show another, the last video.
The basic ISO metric thread
It's
profile is calculated based on the
about
pitch.
its previous figure, and now about tolerance fields of metric threads.
P, height H, major, minor, and pitch diameters. But this profile is subject to tolerance like any manufactured item, and this video focuses on explaining how this works. Let's start with the thread description. General metric threads start with an M, denoting the thread is metric, followed by a number referring to the external thread major diameter. The last number references the pitch. When tolerances are referenced, an extra designation sometimes appears after the pitch. In this example, I've added 5G and 6G. 5G refers to a negative tolerance deviation on the pitch diameter, and 6G is a further negative deviation tolerance on the major diameter. We say negative as the thread cannot be larger than the basic or standard profile. Otherwise, it would interfere with the internal thread associated with the nut. So any tolerance is based on a reduction in size. The internal thread tolerance is accompanied by capital letters, and this means the deviation is positive. The nut internal thread cannot be smaller than the standard profile, so any tolerance must lead to an increase in size. The second letter and number combination for internal threads focuses on the minor diameter rather than the major diameter. Two matching internal and external threads, in other words, the nut and screw thread, share a common major, minor, and pitch diameter. For the screw thread, we will only focus on the major and pitch diameters. We'll call these D and D2 respectively. While for the nut, we will focus on minor and pitch diameters. Let's refer to these as capital D1 and D2. The image on screen now shows how thread deviation works. Let's consider the blue line or zero line as the basic thread profile. Both internal and external threads may deviate, but this deviation must be in opposite directions away from the basic profile zero line. In regards to the internal thread, deviation is above the zero line, and so is considered positive. Capital ES and EL mark the deviation. Deviation positions are categorized using letters. For the metric internal thread, we only use two positions. These are G and H. The external threads deviate below the zero line, so are considered negative. Lowercase es and ei mark this deviation. Lowercase letters are also used to identify the negative deviation. There are many deviation positions for external threads noted from positions A through to H. Internal, external thread, or nut and screw tolerances are driven by the pitch.
Please use your pen and write down the fundamental deviations of internal thread and external thread. For internal thread, it's only big G and big H. And
Okay.
for external thread, A, B, C, D, E, F, and G, and H2. So always between internal thread and external thread, we will have clearance. Can we continue?
Yes, teacher, yes.
Okay.
Lowercase letters are also used to identify the negative deviation. It's noted. No thread or nut and screw tolerances are driven by the pitch. As the pitch increases, more external thread deviation positions become available. Position G and H are available for all threads regardless of the pitch. Here is a diagram of the standard or basic thread profile in blue. With internal thread deviation and tolerance overlaid, EL marks the deviation for tolerance position G. The grey section marks the minor and pitch diameter tolerances applied after the position shift. The only other deviation position available for internal threads is H. H offers zero deviation before tolerance begins, and so tolerancing starts at the basic standard profile. The diagram for the external thread
Please
reverses
look at
the
these
basic
schemes
standard.
again. If we have H, the fundamental deviation of the tolerance field, we have the clearance between fundamental zero line and the tolerance field of the nut. If we have
Yes.
E, we have the clearance between fundamental deviation of the tolerance field of the nut and the zero line, like in this picture 2. We have the clearance here in the outer diameter or major diameter, in the pitch diameter, and in the minor diameter. All three diameters have the clearance between zero line and tolerance field of the nut. H, G. H without clearance between zero line and fundamental deviation of the tolerance field. G with clearance.
So tolerancing starts at the basic standard profile. The diagram for the external thread reverses the deviation and tolerance direction. Position G offers the smallest deviation. Deviation increases at each position up until position A. ES marks the deviation. Tolerances are then applied to the major and pitch diameters.
It's the smallest deviation between this distance between zero line and the tolerance field of the bolt, and the biggest deviation, it's have fundamental deviation A. So it's a biggest distance between zero line and tolerance field of the bolt.
The alternative external thread deviation position is H.
But if we have a fundamental deviation of the nut is H, the distance between zero line and the tolerance field is equal 0 without this distance.
H again offers zero deviation.
Small
before
s is
tolerancing
equal
begins.
0.
Multiple tolerance options are available for each tolerancing diameter. These are known as thread tolerance grades. Smaller grade numbers offer the tightest tolerance. Larger tolerance grades may be selected due to cost or manufacturing difficulties.
Please write down to your notes these grades of tolerance
There are
fields.
extensive charts available.
Internal
for
thread
tolerance.
and external thread.
Okay, teacher.
Internal thread in the nut and external thread of the bolt.
Yeah, okay, teacher.
Grades. I've opted not to show examples here because there are so many. Information on grades can be found in many engineering textbooks. Metric thread tolerancing is also affected by thread engagement. Short, normal, and long thread engagements based on the pitch and major diameters require different tolerances. So, just to round up, let's pull all the information together. Both external and internal threads have a preferred tolerance class
It's very important tables. So please write down these tables into your notes and write down these metric threads. So M12 it's pitch diameter and pitch 1.75. It's 5G, it's pitch diameter tolerance, and 6G major diameter tolerance. If we see small g, small letters, so we can say that it's the thread of the bolt. But if we see big G, for example, or 6H, for example, big H, we can say that it's metric thread of the nut. Always small letters, it's for bolt, and big letters, it's for nut. Internal thread, for internal thread of the nut, used big letter. External thread of the bolt used small letters. Write down, please, these two tables and this metric thread of the bolt. This example of metric thread. So if we need the high tolerance quality, we used IT grade 4 or 5. If we need medium tolerance quality, we used 6 or 7 IT grade. And when we don't need fine or medium tolerance quality, we used coarse quality and 8 or 9 IT grade. In this table, you can see S, N, and L. What is that? It's length of the thread and engagement. Please write down that is S, it's short, N, it's normal, and L, it's long length of the thread engagement. You can see a length of the thread engagement in this picture. It's length of engagement.
Class depending on whether short, normal, and long thread engagement is selected. They also depend on whether fine, medium, or coarse pitches are selected. The external thread description tolerance is for the pitch and major diameters. Tolerance positions E, F, G, and H are preferred for external threads. Any combination shown in the tables here with only one letter and number offer the same class for both diameters. Recommendations are a little more limited for internal threads, but this is because only G and H deviation positions are specified for this.
Please write down to your notes this recommendation for the internal threads of the nuts. You can see it's big letter, so it's internal thread of the nuts. It's example of thread, metric thread, diameter, pitch diameter 12, pitch is equal 1.75, and pitch diameter tolerance and minor diameter tolerance is 5G, big G. And in this table, we can see fundamental deviations that used big letters. Write down to your notes this table and this example of metric thread. .3 total tolerance of the average thread diameter. The accuracy and connectivity of the thread is determined by the average or pitch diameter, the accuracy of which is normalized by the total or full tolerance. We use this formula where delta D suffix 2 is the tolerance of the actual average pitch thread diameter, F suffix P diametrical compensation of thread pitch deviations, F suffix alpha diametrical compensation of deviations of the half angle of the profile. So it was the last slide for today. We finished our lesson. We will continue next time in the next week. So thanks to you.
Yeah, thank you.
And,
Thank you.
goodbye for today.
Yeah, thank you so much.
Good luck.
Bye. Have a nice day.
Have a nice day.